Welcome to DrupalBrief. This is an AI-generated summary of another video, podcast, or blog post. If you want to learn more about what's being discussed here, then please go check out the source. This podcast is sponsored by Drupal Forge. Drupal Forge is an open-source, lightning-fast demo, development, and testing platform. It spins up Drupal sites in less than 5 seconds, complete with a browser-based VS Code. Want to try Drupal CMS, Drupal AI, Experience Builder? No need to install anything on your laptop. Drupal Forge has you covered. Even Composer, Drush, and AI keys are pre-installed so you can hit the ground running. Demo Drupal in less than 5 seconds only at Drupal Forge. Please take a second to click subscribe. We're a new podcast and this helps us a lot. Okay, that's it. Ready? Here we go.
Okay, let's unpack this. If you're trying to keep up these days, you're hearing terms like LLMs, vector databases, agents, even hallucinations thrown around constantly. It can seriously feel like you need some kind of secret decoder ring just to follow the conversation. But here on the deep dive, our mission is pretty simple. We want to cut through that noise. We're here to demystify these really powerful AI concepts, give you a clear shortcut to being genuinely well-informed, without that feeling of information overload.
Exactly. Think of this as a safe space to learn. Honestly, a lot of engineers sometimes create new terms for things that already exist, which just makes it harder than it needs to be. We promise to keep it as simple and straightforward as possible, giving you that solid foundation.
So what's the journey today?
Right. So we'll start with the basics. What is an LLM, really? Then we'll get into how we talk to them prompts. After that, how we give them reliable, up-to-date info using vector databases and this thing called argre. And finally, we'll move into the exciting world of agents, but also cover the really crucial stuff like hallucinations and data privacy. You need to be aware of those.
Perfect. Let's dive right in then. The absolute core. What exactly is an LLM? You hear all sorts, maybe some kind of super brain, but I gather the reality is, well, maybe a bit different.
It is, and it's actually quite elegant when you break it down. At its core, an LLM is a very, very good autocomplete. That's pretty much it. It's trained on just massive amounts of text. Think the whole internet, encyclopedias, books, everything. And from that, it learns patterns. So if it sees my name is, it learns there's a super high probability the next word is something like Michael or Sarah. When you scale this up with enough data and computing power, this prediction skill gets so good it can answer complex questions, write original text, even generate code, all by predicting the next most likely word or token.
Wow. Okay, so a super autocomplete, a prediction engine. Does it have different phases in its life, like how it learns versus how it works day to day?
It absolutely does. There are 2 main stages. First is the training stage. Think of this as the LLM going to university, basically. It's where it learns from all that massive data. Now, this is the really, really expensive part. We're talking millions of dollars, huge clusters of GPUs, massive energy consumption. Very few companies actually do this. OpenAI, Anthropic, Google, XAI, those kinds of players. It's rare.
Okay. Millions for training. What's the second stage?
That's the inference stage. This is when it's actually doing the job, running the model, answering your question. And the key thing here is cost effectiveness. Inference is usually charged per request, and it only runs while it's generating the answer. This makes it dramatically cheaper, sometimes just cents per request. It's why you or I could potentially run a model on our own machine or even a powerful phone these days. The cost difference between training and inference, it's like millionfold. Huge difference.
Right, that clears up a major point. So a smaller company, maybe 50 people, they can realistically use these powerful models. They're not footing the multi-million-dollar training bill, just paying for the actual usage, the inference. That's really important.
Exactly. It democratizes access significantly.
Okay, so we have this incredible prediction machine, but how do we actually tell it what we want, getting it to generate useful output, not just random text? Is it just typing a question?
Well, that's where the art comes in, and that's all about prompts. A prompt is simply the instruction or the task you give the LLM. When you type into ChatGPT, that's your prompt. And here's something fascinating. The quality of the AI's output often has much more to do with how good your prompt is than even the underlying model training itself. That's a key takeaway.
So prompting is crucial. What makes a good prompt then?
Yeah.
Are there techniques?
Definitely. There are several key strategies. First, clear, scoped instructions. Be super specific about what you want. Don't be vague. Second, something called few-shotting. I have no idea why people come up with these names, but that's what it's called. It just means giving the LLM a few examples of the kind of output you want. Like, show it a previous thank you letter if you want it to match that style.
Okay, few-shotting. Give examples. Makes sense.
Third, specify constraints and style. Tell it how long the response should be, the tone, formal, casual, funny, or specific things that absolutely must include. And finally, request specific output formats. If you need Markdown, HTML, JSON, whatever, ask for it. Giving an example of the format helps too.
This really sounds like a skill in itself. Is prompt engineer actually a job title people have now?
Oh, absolutely. It's a rapidly growing field. Prompt engineering is a specialized skill. There are prompt libraries, even validators. Anthropic has one to help write effective prompts. That said, we probably all need to learn the basics, like we all learn to drive a car. But not everyone needs to be a Formula One driver or a specialist prompt engineer. Basic proficiency will become standard.
Okay. And I think you mentioned there are different types of prompts.
Yes, that's right. There are generally two types that work together. First is the system prompt. This is like the foundational rule set you define once. It sets the LLM's persona, its guardrails, its core instructions, maybe something like, you are a helpful assistant specializing in U.S. visa law. Do not discuss other countries' laws. A site builder might set this up.
Got it. Fixed rules. And the other type?
The user prompt. This is what changes with each specific request. It's the actual question the user asks, like how long can an L1 visa be extended? The LLM gets the system prompt first, digests those rules, and then gets the user prompt. This system prompt is really powerful for things like refusals do not talk about X, or setting default behaviors like, unless the user specifically asks for a long answer, keep responses concise, maybe 2 or 3 sentences.
Right. So we have the LLM, we have prompts to guide it. But what about information that changes all the time? Or information that's specific to my company that wasn't on the internet when the model was trained? That seems like a big limitation for accuracy.
It is. Or it was a huge limitation. This is where vector databases are fundamentally changing the game. Honestly, if you learn one technical thing today, maybe make it a vector databases. They're like the new Solar search, but much more powerful. They solve the limits of old school keyword search.
How so? What's the difference?
Okay, so traditional keyword search, think older search engines, matches exact words. If you search Italian, it finds documents with the word Italian. Simple matching. Vector databases understand meaning. They use something called embeddings to turn text into numbers vectors that represent its semantic meaning. In this multidimensional space could be like 100,000 dimensions. Words or concepts with similar meanings, like Italian and Italy, are placed closer together mathematically.
Whoa.
Yeah. So if you ask for an Italy recipe, the vector database can find documents about Italian recipes because it understands those concepts are related, even if the exact word Italy isn't there. It's searching based on meaning, not just keywords.
It's a huge leap.
Yeah.
Meaning-based search. So how do we connect that capability with our LLM to get those accurate, fresh answers we need?
That connection is called RAG, which stands for Retrieval Augmented Generation. Look, the simple way to think about RAG is just AI search. If you think of it that way, you're probably 99% correct. It's a pretty good analogy.
AI search. Okay. What problem does it solve?
It solves the problem of giving the LLM specific, relevant, and current information right when it needs it without overwhelming it. Instead of trying to stuff, say, details about 50 different visa types into one massive prompt, or hoping the LLM somehow magically knows the latest rule change, RG lets you retrieve only the information about the L1 visa when the user asks about the L1 visa and feed just that to the LLM alongside the question.
Targeted information delivery.
Exactly. And the benefits are massive. The information is fresher because it comes from your live database, it's way more accurate, and it drastically reduces those AI hallucinations we talked about earlier.
Can you walk us through how that works, maybe with that visa example on a Drupal site?
Sure, let's do it step by step. 1, document preparation or embedding. You take your source documents, maybe Drupal nodes, each describing a visa type. You run these through an embedding model. This converts the text into those numerical vectors, those numbers we talked about, and you store these numbers in your vector database. This usually happens once or whenever the content changes. Systems like Drupal's Search API can manage this.
Okay, content embedded and stored, step 2.
2, user query. A user asks a question like, how long can L1 visas be renewed?
Standard user question.
Then 3, vector database retrieval. The system takes the user's question, embeds it to, and queries the vector database. The database finds the chunks of text, the document snippets, whose vector embeddings are semantically closest to the question's embedding. So it might pull back info snippets about L1, maybe L2, L3 visas because they're related. Crucially, it's not the answer. It's the relevant source material.
Okay, it retrieves relevant documents. Step 4.
4, LLM generation. Now, the LLM receives several things: the standard system prompt, the user point, the actual question, and this retrieved relevant content from the vector database. And here's the crucial instruction, usually in the system prompt. Only use the information found in the provided content to answer the question. Ignore any other knowledge you have about visas. This forces it to use the fresh, accurate data.
Ah, okay. Grounding it in the provided facts.
Precisely. And finally, 5, answer. The LLM synthesizes the information from the retrieved snippets and gives a concise answer, like L1 visas can typically be renewed up to a maximum of 7 years, based only on the provided text.
That is incredibly powerful. But what if the source data itself is wrong? Like the Drupal node has a typo? Or what if the vector search doesn't find anything relevant? Can it still go wrong?
Absolutely. Great points. First, garbage in, garbage out. If the information in your source documents, your Drupal nodes, is wrong, RAG will feed that wrong information to the LLM and you'll get a wrong answer. This just highlights how important it is to keep your source content accurate and up to date, which again, tools like Drupal's Search API help manage.
Okay, so accurate source data is key. What about the retrieval failing?
Right. If the vector database doesn't return anything relevant or the information is incomplete, a helpful LLM might just, well, make something up based on its original general training. Hallucinate, essentially.
How do you stop that?
System prompts are vital here. You must explicitly tell it. If you do not find relevant information in the provided content, you must state, I do not know. Do not invent an answer. We had this happen. We called it the banana problem. The LLM knew bananas are grown in, say, 3 main regions globally from its training. Our client's data, provided via our reg, clearly show they only source from 2 regions. But unless we explicitly told the LLM in the system prompt, for the purpose of this answer, bananas only come from these 2 specific countries, it would confidently list all 3, even with the correct data right in front of it.
Wow, that's specific.
We had to go that far. It really shows you need rigorous testing. You need domain experts trying to trick it, asking edge case questions, not just the obvious ones, to make sure it's reliable.
Okay, RE is the main way to feed current info. What about fine-tuning? You hear that term too. Is that another way to add knowledge?
It is a way to modify a model, but it's fundamentally different from ARG and honestly much less common for just adding knowledge. Fine-tuning is like, imagine the LLM had already gone to university, initial training, and started its job, inference. Fine-tuning is like sending it back for a very specialized, intensive post-grad course. You take a pre-trained model and train it further on a specific, smaller data set to adjust its behavior or specialize its knowledge deeply, like taking a general law model and fine-tuning it only on U.S. patent law to make it an expert in that niche.
Okay, so it's more about changing behavior or deep specialization.
Exactly. And the big drawback, you're back in that super expensive, time-consuming training world. GPU clusters, weeks of work, potentially millions again. So here's the crucial distinction. In my experience, for probably 99% or more of use cases where you need the AI to know new facts or updated information, RG is much, much better.
Why better?
Our RAG handles content changes, instantly update the document, re-embed, done in seconds. It's explainable, you know, why the LLM gave an answer because you see the source text our RAG provided, and it's vastly cheaper. Fine-tuning is really only for those very specific, high-value, long-term scenarios where you need to fundamentally alter the model's core style or reasoning, not just give it new facts. Honestly, sometimes companies might try to sell you expensive fine-tuning projects. It can sound a bit like snake oil. You can achieve so much more, much faster and cheaper with good RAG implementation.
I have a quick question for you. Are you still spinning up Drupal sites the old way? If it's working for you, then great. But if you want to move faster, then listen up. Drupal Forge is now the fastest growing demo, development, and testing platform used by developers, testers, contributors, and trainers across the world. Need to spin up a quick demo? Done in seconds. Want to test a new module? Instant environment. Building a training course? Perfect sandbox ready to go. And here's the cool part. Got a template that others could use? Share it publicly or keep it private for your team. All at Drupal Forge. Stop wasting time on setup and start building faster. Okay, that's it. Back to the show.
That's a really helpful clarification. So thinking about some recent controversies, maybe where an AI's responses suddenly became problematic, maybe sounding Nazi-like, as was reported in one case.
Yeah.
That sudden change, that's almost certainly a prompt change, not fine-tuning.
Oh, 100%. Absolutely happened at the system prompt level. Fine-tuning to instill that kind of specific, undesirable behavior would take weeks or months. A system prompt change, that can be deployed almost instantly. Big difference.
Right. Okay. So we've covered LLMs answering questions using ORAV for accuracy. But what about getting them to actually do things, interacting with other software, automating tasks?
Yeah, moving from just talking to acting. That's where a newer concept, MCP, or Model Context Protocol, comes in. Honestly, it's basically APIs for LLMs. I don't know why we don't just call it that. But MCP is the term gaining traction.
Okay, APIs for LLMs. What makes MCP different from a regular API?
It adds a layer of context. A standard API just passes data back and forth. MCP defines a way for the LLM to understand what a tool does and what kind of response to expect when it calls that tool. Crucially, it includes constraints. So the MCP definition for a LinkedIn posting tool would tell the LLM, this tool posts to LinkedIn and the text cannot be more than 500 characters. The LLM knows the rule before it even tries to generate the post.
So it's a smarter, context-aware connection.
Exactly. It's like a universal adapter between the AI and your existing tools with built-in understanding. Lots of services are offering MCP endpoints now, Google Drive, LinkedIn, etc. And platforms like Drupal can already integrate with these. You could genuinely ask Drupal, load the latest blog draft from my Google Drive and create a new post on the site.
Or
take this blog post I just wrote in Drupal, summarize it for LinkedIn, making sure it's under 500 characters, and post it. Drupal, using the LinkedIn MCP, handles the interaction and enforces the constraint.
Okay, this is starting to sound really powerful. Moving beyond Q&A to actual action. That brings us to agents, right?
Precisely. This is where it gets really interesting. A standard LLM answers a question. An agent takes it further. You ask an agent to perform actual actions for you.
Actions like?
Well, the wild example is asking it to renew your visa. Theoretically, an agent could find the right government form, connect to a secure MCP server holding your personal info, fill out the form, and send you the completed PDF. That's futuristic, maybe.
Okay, maybe a bit far off. What about now?
Right now, in Drupal, for instance, you can already have agents do things like create a new content type called events with fields for date, location, and description, or build a view page that shows all published event content sorted by date, and even generate 10 realistic-sounding test event examples for me. It can do these administrative actions.
So an agent is like a specialized worker AI.
That's a great way to put it, like a teammate with a specific, narrow functionality. It could be a Q&A assistant using Argry, or it could automate reporting. Like Drupal agent, use the LinkedIn MCP to check the click stats for my last 20 blog posts, figure out which one performed best, and give me a summary report. That's achievable today.
Okay, so one agent does one task. But real work is often complex, multi-step, like write a blog post, get it proofread, then translate it. How does that work?
Now you're hitting on the really hot stuff right now. Agentic frameworks, that's the fancy term. Instead of just one agent doing one thing, you have a kind of leader or orchestrator agent that coordinates multiple specialized agents to handle a complex multi-step workflow.
Like a project manager for AIs.
Kind of. So for your blog post example, Agent 1, content writer, generates the draft. The leader agent passes it to Agent 2, proofreader. Agent 2 checks it. Maybe it finds issues and sends it back to Agent 1 for revision, coordinated by the leader. Once Agent 2 approves, the leader passes the final text to Agent 3, translator. Maybe even multiple translator agents, perhaps using different LLM models that are best for specific languages, like German versus Japanese.
Wow.
Yeah, it's like a team in a company, right? You have front-end devs, back-end devs, QA, UX, different skills. Agentic frameworks bring that specialized collaboration to AI workflows. And again, platforms like Drupal are actively building support for these agentic frameworks, enabling really sophisticated automation. It's amazing how fast this is moving. A couple of years ago, just getting a coherent answer from an LLM was exciting. Last year, maybe an agent doing one or two things. Now, these multi-step, cross-tool, multi-model agentic workflows are the cutting edge.
This is incredibly powerful stuff. But we have to talk about the downsides. We mentioned hallucinations earlier. What exactly are they and how worried should we be?
Right, the elephant in the room. I personally see hallucinations like dealing with an overeager, super confident intern. They just came out of their training, they think they know everything, and they generate answers that look really polished and confident, but they're just plain wrong.
We've all seen the stories, right? Lawyers citing fake cases in court filings.
Exactly. Or AI helplines giving dangerously wrong advice. It happens. Usually it's because the AI is missing context, it's overgeneralizing from its training data, or the prompt was just too vague.
So it's just making things up.
Well, technically, a model is always kind of hallucinating. It's not remembering facts like a human. It's a probabilistic machine, always predicting the next word based on patterns it learned. The problem is, we humans like confident answers, so models are often trained or prompted to sound confident, even when their internal probability for that answer isn't actually that high. Confidence doesn't equal correctness.
Okay, that's a bit scary. How do we manage this? How do we reduce the risk?
Thankfully, there are several effective strategies. Number one, as we discussed, RAG, AI search. Giving the LLM high-quality, specific source material to base its answer on is the single best defense. It's like giving that intern the actual company policy manual to read instead of letting them guess. It can always look back at the provided text.
Okay, RG first. What else?
Second, citations. Force the LLM to cite its sources for claims it makes, ideally linking back to the specific part of the REG provided text. If it can't find a citation, it's much less likely to just invent something. Third, system prompts. Be really strict. Use clear scope constraints and that explicit instruction. If you don't find the answer in the provided documents, say, I do not know.
Right, the don't guess rule.
Fourth, for really critical tasks, request structured output, like JSON. If the LLM hallucinates badly, the JSON structure will likely break or be malformed. It's an error check. If the JSON is invalid, you know something went wrong. And finally, the best solution, honestly, humans in the loop. Especially for sensitive applications, have a human review and approve the AI's output before it goes live or is sent to a customer, like a support bot drafting an answer for a human agent to quickly verify.
Makes sense. Human oversight is key. Now, beyond what the AI says, what about what it sees? Data privacy, personal information, PII, what are the big concerns there?
This is absolutely critical. PII, personally identifiable information, needs careful handling. First, understand that LLM providers are frankly desperate for data. They're kind of running out of new, non-AI generated text on the internet to train on. So user queries become a really valuable source of fresh, human-generated data. Even if a company says, we don't train on your specific prompts, they are definitely analyzing the types of questions people ask. They might see millions of questions about, say, healthcare, and decide their next model needs much better training in that domain. Your queries inform their strategy, even if not directly used for training word by word.
Okay, so our questions become market research for them. What else?
There's the honeypot risk. These AI companies are collecting unimaginable amounts of potentially sensitive query data. This makes them massive targets for hackers. A breach could expose vast amounts of user information.
Right, like any large data aggregator.
Exactly. And related to that is control over data. You need to be really careful where your data, and especially your customers' data, ends up. Think about it. Who knows who will own OpenAI or Google's AI divisions in 10 years? Remember 23andMe? People submitted DNA, then ownership changed, and suddenly many felt concerned about who had access to their genetic information. Same principle applies here. So when deploying AI, think carefully about hosting. Choose regions, choose providers that align with your data protection requirements and the relevant local laws, like GDPR in Europe.
Really crucial points. Okay, we've covered a lot of ground here. Bringing it all together, what are the key takeaways for someone listening, wanting to actually start using this AI power responsibly?
Okay, let's summarize. First, start simple. You can get incredibly far with just good prompts and solid REG implementation. Don't immediately think you need expensive fine-tuning. You probably don't. Second, if you want your AI to interact with your other tools, think MCP. It's just a smarter API. That's the main idea. Third, if you need more than just Q&A, if you need the AI to perform multi-step tasks, then agents and agentic frameworks are the way forward. And the exciting part is that platforms you might already use, like Drupal, are building all this in. Fourth, for hallucinations, context is king. Use REG, demand citations, use strict system prompts, consider structured output, but always remember a human in the loop is your best safety net for critical applications. And finally, be vigilant about data privacy and PII. Know where your data is going.
That's a fantastic summary. You know, listening to all this, the speed of change, the power, it brings a thought to mind. It's something people say often now, but it really resonates after this conversation.
So what?
You won't be replaced by AI. You'll be replaced by somebody using AI.
That's exactly it. Think about history, right? When cars first came out, people who owned horse carriages fought against them. They pointed out the dangers, the noise, the pollution. They resisted. But cars were just 10 times faster, 10 times more efficient for many things. And well, how many professional horse carriage drivers do you see on your commute today? Resistance is understandable, but adaptation is crucial. It really is time for everyone to start learning, experimenting, and figuring out how to integrate these tools.
A powerful closing thought. This deep dive has given us, and hopefully you listening, a really solid foundation to navigate this complex landscape. Now go forth and explore the possibilities. Thanks for joining us.
That is a wrap on today's Drupal brief. Remember, this was an AI-generated summary, so be sure to check out the original source for the full story and all the details. Before you go, if what you heard today got you excited about trying something new in Drupal, remember that Drupal Forge has you covered. Whether you want to test that new module, demo a concept to your team, or just explore the latest Drupal features, you're literally 5 seconds away from a fully loaded development environment. No downloads, no setup, no hassle. Just pure Drupal innovation at your fingertips. If this episode was helpful, please hit that subscribe button and leave us a review. It really helps other Drupal developers discover the show. Thanks for listening, and we'll catch you on the next Drupal Brief.